Okay, good day, folks. Welcome to my YouTube channel. Don't forget to subscribe and like my video and watch my video till the end. Share with your families and friends. Let's cut the chase. We're going to look at the intermolecular forces. What are the intermolecular forces? The intermolecular force, it's a force that is between molecule. Let's look if we have this molecule and this molecule. So the force that occurs between the two molecule, it's an intermolecular. So the intermolecular force is a force that occurs between molecules. So if you look at this is a hydrochloric acid and hydrochloric acid. So the force that occurs between the two, it's intermolecular force. Between this molecule and this molecule, it's intermolecular force. But now there's a type of force as well. We call it's an intra-atomic force, or the intramolecular, not intermolecular, the intraatomic or the intra molecular attraction. So the intramolecular attraction or intraatomic, it's between, it's within the molecule. So you have this molecule, so there's the force between this atom and this atom, it's an intramolecular force. So this force, it can be a covalent bonding, ionic bonding, metallic bonding, right? So even it's written here, if you look at this drawing, you have this atom and these atoms. There are three. Water, it's like that. So normally this is hydrogen and oxygen in water. So the force between the hydrogen and oxygen, this force between, or this bond, we call it's an intra, and an inter, it's between. Okay guys, let's look at the type of intermolecular forces. The type of intermolecular forces, the one that we're going to look at first, it's the dipole force. So what do we mean by dipole? We mean a substance that is what is polar. So it's polar and polar. So when we say dipole, it's a force that occurs between the two polar molecules, right? Now, the force that occurs between two polar molecules, let's take the HCl again. The HCl and HCl. So the HCl molecule on its own, it's a polar molecule because chlorine has a greater electronegative than hydrogen. So chlorine, it's going to be slightly negative because it attracts the shared pair of electrons towards itself more than hydrogen. So this one is going to be slightly positive, slightly negative, because the dipole moment, it goes to hydrogen. So the force that occurs between the two molecules, it's an intermolecular force. But what type of intermolecular force? Because hydrogen, the HCl, it's what? It's polar. And this HCl is what? It's polar. So it's a force that occurs between the two polar molecules, this polar and polar. Because if you look at here, the net dipole moment, there will be a net dipole moment here, there will be a net dipole moment there. So it's a polar. So this type of force, we call it's a what? It's a dipole force, because it occurs between the polar molecules. Now let's take another one. Let's take another example. Let's say we have water and we have KBr. It's water and potassium bromine. So the one that has a greater intermolecular force between let's look at the KBr. The KBr, it's a linear molecule just like HCl. Br has a greater electronegativity than the potassium. So the potassium is a smaller one. So once it's like this, that means the KBr, it's what? It's polar, because there's a net dipole moment. And as I've mentioned in water, it's what? It's a polar molecule. Look at my previous video in the polarity of molecules. So this force, it occurs between the slightly negative and the slightly positive. So the K here is going to be slightly positive and this is slightly negative. So the force that occurs between the two, we call it's a, between its polar molecule, it's a dipole force. So a dipole force is a force that occurs between the two polar molecules, right? Now, let's look at the hydrogen bonding. Hydrogen bonding, it says it's forces between molecules in which a hydrogen is covalently bonding with a nitrogen or oxygen or fluorine. A specific case of dipole, a special case of dipole. So the hydrogen bonding, guys, it's the force that occurs between the hydrogen of the other molecules and the other molecule. It has to have the NOF, one of the smallest highly electronegative. So it must, the other molecules, it occurs between the hydrogen of the other molecules, the nitrogen. Okay, let me draw it, guys. Let me draw it. So let's say we have this molecule. Let's say we have this molecule here. So this molecule, guys, okay, let me make it easy. This molecule here, and this molecule is polar. How do we know it's polar? So between, if you look at this bond, the CH bond, CH bond, CH bond, it's the same bond. So between carbon and hydrogen, the one that has a highly electronegative, it's carbon. So the dipole moment, it's going to be towards carbon, So this vector and this vector will cancel. It's the same magnitude in opposite direction. And then this vector, it's going in that direction, and between carbon and Br, it's going to go in which direction? To this direction. So as I've mentioned, that these two, they're going to cancel. You're going to be left with that. So you'll have a greater vector, this plus this, it will be a greater vector. So you have a dipole moment. So we can conclude that this one is what? It's polar, because there is a net dipole moment. Net dipole moment is not equal to 0. So let's take another molecule. Let's say this molecule is HCl. We know HCl is polar. No, let's take hydrogen fluoride. So this one is polar as well. Guys, all the linear molecules are polar like this. The hydrogen highlights, they're polar. So this one is polar. So now what I was saying, the hydrogen bonding occurs between a molecules in which hydrogen is covalently bonded to nitrogen. Or so now in this one, we're going to look at the hydrogen. This hydrogen is covalently bonded with let's look at this hydrogen. In this so it's a hydrogen in this molecule is covalently bonded. Let me change the way. Let me put them in a different orientation. Let me put it like this. Okay, so if we put them in that orientation, so the force between the hydrogen of the other molecule, so we're going to look at this hydrogen. So it's a force that occurs between the hydrogen of the other molecules and the fluorine or the nitrogen or the oxygen. So one molecule, it's hydrogen. The other molecule, it must have the NOF, which is the nitrogen and oxygen and fluorine. So the force that occurs here, it's between this hydrogen and this fluorine. So this type of bond, we call it, it's what? It's hydrogen bonding. Remember, the requirements for hydrogen bonding, guys, it has to be polar and polar molecule. That's why it says it's a special case of a dipole force. It has to be polar. But one of the polar molecule, it must have nitrogen, oxygen, and fluorine. So this one, it has a what? A fluorine. So it's going to have a force of attraction, the hydrogen and that fluorine. Guys, let's look at another example. Let's take water, and then we're going to take HCl, right? So between these molecules, guys, we know water is what? Is polar. So water is a polar molecule. And as I've mentioned, guys, the HCl, HF, HBr, HI, they are polar. This is polar as well. So the force that occurs between polar molecules is one of the requirements of the hydrogen bonding. But now let's look at one molecule. Does it have the NOF, which is the nitrogen or oxygen? So we have this molecule. It has the oxygen in the north. So the other molecule, we look at the hydrogen. It has the hydrogen, but it's polar as well. So the intermolecular force between this oxygen and the hydrogen, we call it, it's a what? It's a hydrogen bonding. It's a hydrogen bonding. Another example, guys, it's a dipole induced dipole. The dipole induced dipole, that means, guys, it's a force, as it's written here, it's a force between the polar molecule and the non-polar molecule. So that means it's a polar molecule, it makes the non-polar to be polar. It's a polar induces, which means makes the polar. So which means it was a non-polar, but it's made to be a polar. Now let's look at this polar molecule. Let's take let's look at, let's say now it's what? It's HCl, and then which is, it's going to be a polar, and then let's take the non-polar. The non-polar, it's a methane, this one, methane. Now between these two, the force between these two, guys, this one is going to be slightly positive, slightly negative, between these two, guys, because this is polar and this is a non-polar. How is this a non-polar? Because there's a dipole moment there, same dipole moment there, but in opposite direction they cancel, and there's a dipole moment there and the same dipole moment, but in opposite direction it cancel. So here, net dipole moment, the net dipole moment is equal to 0. Therefore this is a what? It's a non-polar. So guys, the force that is between this polar and the non-polar, it's a what? It's a dipole induced dipole. So this polar will make this non-polar to be what? To be polar. It's a dipole induced dipole. Let's take another example between the dipole induced dipole, which is a polar and non-polar. Now let's take the water. Okay, let's take the oxygen, which is the oxygen, it's like that, and water, it's like that, right? So we know water is what? Is polar, and the oxygen, it's a diatomic molecule. All the diatomic molecules, they are what? They are non-polar. So it's a dipole and a non-polar. So this polar will make this one polar, but it's momentarily. So there's a force between the two. So this one, we call it, it's a what? It's a dipole induced dipole. Basically, this polar molecule, it's making this non-polar molecules to be polar. Okay, let's look at another one. This one is is the mutually induced dipole, which it's a London force. So the London force is when they're mutually making themselves polar. They are non-polar. They are making themselves to be polar, but they are non-polar. It's a force between non-polar molecules. So let's have the non-polar molecules here. It's a it's a London force. We call it, it's a London force or London dispersion. Let's take the two non-polar molecules. Let's say we are taking we are taking hydrogen bonding, the hydrogen and hydrogen, sorry, not hydrogen bonding. So the force between these two, this is a what? This is a non-polar, and this is a what? It's a non-polar as well. So the force between the non-polars, we call it, it's a what? It's a London. It's a London force, because this non-polar will make this one to be polar, and this polar will make this one to be polar. So they mutually making each other polar. So any non-polar molecule, it's a non-polar molecule force between, it's a London. Now we have the force that is called iron dipole force. The iron dipole force, it's a force between the iron and the polar molecule. It's a force between iron and the polar molecules. Let's say we are having the sodium chloride in water, So the sodium chloride in water, what's going to happen here? This chlorine, if you dissolve the sodium chloride in water, it's going to split into pieces. The chloride, it's going to stand there, and that it will be sodium ion. So this ion, it's a force between this chloride ion and okay, let me put it this way. The chlorine, it's going to be attracted with the hydrogen, because hydrogen is slightly positive, the hydrogens, and the oxygen is slightly negative. So this chlorine will be attracted to the hydrogen. So we call this is an ion, it's a chloride ion, and the polar molecule, so it's an ion dipole. Okay, let me put it this way. It's an ionic compound, the sodium chloride. It's an ionic compound and the polar molecule. So it's a force between this ionic and this polar. We call it, it's an ion dipole. It's between the ionic compound and the polar molecule. It's an ion dipole. The ion induced dipole. That means it's a force between the ion and the nonpolar. So that nonpolar will make that ion. Sorry, it's a force between ion and a nonpolar. It says force between the ions and a nonpolar molecule. So this simply means that the ion will make the nonpolar to be polar. Let's look at the ion. Let's take the KBr in this case. This is an ionic. This is an ionic compound. It's an ionic molecule, whatever. So we have the nonpolar. Let's say the nonpolar in this case, it's going to be the carbon dioxide. In this case, it's going to be, let me write it like this. It's the carbon dioxide. So this ion will make the carbon dioxide, guys, it's a what? It's a non-polar. So this ion will be attracted to this non-polar, so this ionic compound. So this ion will make this non-polar to be polar. It induces, the word induces, that means it makes us to be polar. The strength of the intermolecular forces, guys, We I ranked them according to the strength of the intermolecular force. So the one that has the greatest intermolecular force, which is the strongest intermolecular force, is the hydrogen bonding, and the one with the lowest intermolecular force is the London. Remember the London, it's the non-polar and non-polar. So I rank them according to the from the highest to the lowest. It's a descending order of the strength of the intermolecular force. Guys, we have what we call it's the physical properties. So we call it's a boiling point, and we have the melting point, and we have the vapor pressure, right? So these vapor pressure, we call them physical properties, right? Physical properties of molecules. So guys, the melting point and the boiling point, they're directly proportional to the intermolecular force. So if a compound has a greater intermolecular force, that means its boiling point it's going to be high, and its melting point it's going to be higher. So the compound with the lowest melting point and the lowest boiling point, that means its intermolecular force is what is weaker, right? So, guys, the intermolecular force and the boiling point and the melting point are directly proportional. Greater intermolecular force, greater boiling point and melting point. Now, let's go to what we call that's a vapor pressure. Guys, you must know the definitions according to the exam guideline of these. Now, the vapor pressure is inversely proportional to the intermolecular force. So, the substance with the greatest intermolecular force, it will have the lowest vapor pressure, or the substance with the lowest intermolecular force, its vapor pressure will be high. Right, that's very important, guys, to differentiate that.